In this lesson, we want to look at primes and prime factorization. First thing we need to do is find out what a prime is. A prime number is a number that's only divisible by itself and 1. In other words, it has only two factors, 1 and itself. So in the case here, we have 5. So 1 and 5 are the only factors. 7 is also a prime number. The only factors it has is 1 and 7. Is only divisible by 1 and 7. Okay, 2 is also a prime number, and it's only divisible by 1 and 2. Now, if you have a number that has more than two factors, you have what's called a composite number. And the thing about a composite number is that every composite number has a unique prime factorization, and I'll show you what that means. Let's take the case of 15. It has three factors, 1, 3, and 5, and notice that 3 and 5 are prime numbers. That's the prime factorization of 15. 20 has 2 squared and 5. The 2 and the 5 are prime. Now, there's a guy named Aristophanes in about 200 BC came up with what's called the sieve of Aristophanes. And let's suppose that we wanted to find all the prime numbers from 1 to 25. I'm just going to drop off 1 because it's not prime. Now, this is how this works. Take the first prime number, 2. Divide 2 into all the numbers and see which ones it goes into evenly. And the ones it goes into evenly, cross them out. 3, do the same thing. It's the next prime number. See which numbers it divides into evenly and cross those out. Let's go to 5. See what numbers 5 divides into evenly, cross those out. And then we can go to 7. Now 7 won't divide into any of the numbers that are left, so all the rest of the numbers are also prime numbers. So we have 2, 3, 5, 7, 11, 13, 17, 19, and 23 are all the prime numbers from 1 to 20, 25. All right, that's a little historical thing here. Now let's look at 39. I want to find the unique prime factorization of 39. Well, 3 will go into 39, and it will go in there 13 times. Both 3 and 13 are prime numbers. So the prime factorization is 3 times 13. And notice that 3 divides into 12 if you add the 3 and the 9 together. 26, it ends in an even number, so we can divide 2 into 26. It goes in there 13 times. So 2 and 13 are the prime factors of 26. So the dividends are composite numbers that we're working with here. More than 3 factors. So here's a little bigger number, 105. It ends with a 5, so 5 will go into it 21 times. But 21 is still a composite number. So let's divide 7 into 21, and it goes in there 3 times. So now we've sort of broken it down here a little bit, and the 5 and the 7 and the 3 make up the prime factors of 105. So sometimes we may have to work it down that way to make it a little easier. Okay, 60 ends in a 0. We can divide 10 into there, and it goes in there 6 times. Now both 10 and 6 are composite numbers, but they're smaller numbers now, and we can find the factors of those numbers. 6 is 2 times 3, 10 is 2 times 5. Now on the right hand side there we have all the factors of 60, but 2 times 2 is just 2 squared, so 2 squared times 3 times 5, those are the prime factors of 60, and it's unique. 729. Okay, it's a big number, so let's just sort of work it down here. Now, 7 and 2 and 9, if you add that up, that's 18. So 9 will divide into 18, so 9 will divide into 729. And it goes in there 81 times. Now, both 9 and 81 are still composite numbers, but they're a little bit smaller, so we can sort of look at them there and see what their factors are. So 81 is 9 times 9, and then the other 9 that we have. And all those 9s further work down to 3 squares. Now, if you multiply all the 3 squares together, you get 3 to the 6th. You just add the exponents. So that's the prime factorization of 729. We just sort of worked it down till we have easier factors to work with. Uh-oh, here comes Euclid here. He has a number for us. 504. Now, if you add those digits, 5, 0, and 4, let me get out of the way, you'll get 9. So 9 divides into 504, and it goes in there 56 times. And 56 is 2 times 28, and 28 is 4 times 7. And you just keep working it down until you get to all prime numbers, and eventually you get 3 squared times 2 cubed times 7. Thank you.